Hi, welcome back. Yeah, previously we've been able to apply Pascal's triangle to expand this. Okay, so how do we use a binomial expansion formula? So how do we do that? Let's see how we can um, evaluate this using binomial expansion formula. Okay, although let me clean this answer so that we can compare and see what results we are going to get. So but before we proceed, I believe you still remember um, the formula we use for combination. When you say n combination r, it's n factorial over n minus r factorial r factorial. So which means if you have, for instance, 5 combination 2 is going to be 5 factorial over 5 minus 2, which is 3 factorial 2 factorial. And what does factorial mean? 5 factorial means 5 times 4 times 3 times 2 times 1. So that's it. So that's what you're going to be using to expand this. So how do we now apply it? Okay, let's see how to apply this uh, formula. Okay, so we have 1 plus 2x raised to power 6, and that's going to be equal to, this is power 6, and that's going to be our n. Okay, so the first combination is going to be 6 combination 0. That will serve as our what? This combination, we are going to be using combination for our initial coefficients. Unlike just like the way we used just like the way we used Pascal's triangle in our previous video, we are going to we use that Pascal's triangle for our initial what coefficient. So for this case, we are going to be using a combination to sort out the initial coefficient. Okay, so the first coefficient is going to be 6 combination 0 multiplied by 1 raised to power 6 by 2x raised to power 0. Okay, so I'm going to be having this plus the next one is going to be 6 combination 1 times 1 raised to power 5 2x raised to power 1. Just like the previous, not just like in the previous video, as the power of the first term is reducing, the power of the second term is increasing. So and the sum of those powers must be equal to what? The initial power. Okay, all right, so we're going to be having this plus 6 combination 2 1 raised to power 4 times 2x raised to power 2. Okay, plus 6 combination 3 times 1 raised to power 3 2x raised to power 3 plus 6 combination 4 times 1 raised to power 4 times 1 raised to power 2, rather 1 raised to power 2 2x raised to power 4. Okay, so plus 6 combination 2 times 1 raised to power 2 2x raised to power 1 raised to power 1 2x raised to power okay, combination 5 2x raised to power 5, then plus 6 combination 6 times 1 raised to power 0 times 2x raised to power 5. Okay, so now let's have the whole thing simplified. So here is 6 factorial over 6 minus 0 factorial, that's 6 factorial, 0 factorial, multiplied by 1, multiplied by 2x over 0 is 1, plus 6 combination 1, that's 6 factorial over 6 minus 1, which is 5 factorial, then 1 factorial, times 1 raised to the power 5 is 1, so times 2x to the power 1, that will be 2x, plus the next one, 6 combination 2, that's 6 factorial over 4 factorial, 2 factorial, times 1 times 2x to the power 2, that's 4x squared, plus 6 combination 3, that's 6 factorial over 6 minus 3, that's 3 factorial, and 3 factorial. So times 1 times 2 raised to the power 3, 8x over 3, plus 6 factorial, 6 minus 4, 2 factorial, then 4 factorial, times 1 times 2 raised to the power 4, that's 16, 16x over 4. So here we have plus the next one, okay, is 6 combination 5, which is 6 factorial, 6 minus 5, that's 1 factorial, then 5 factorial, times 1 times, what do we have there? 2 raised to the power 5, which is 32, 32x to the power 5, plus 6 factorial over 6 minus 6, 0 factorial, 6 factorial, then times 1 raised to the power 0 is 1, multiplied by 2 raised to the power, oh, this was supposed to be 6, so 2 raised to the power 6, that's 64, 64 times, okay, that's it, 64x raised to the power 6. So cleaning all of these up, I'm going to be having this out, so everything is going to be 1 plus okay, this will be 6 times 5 factorial over 5 factorial, okay, times 1 times, okay, let's just say times 2x, alright, plus 6 times 4, 6 times 5, 6 times 5, that's 4 factorial over 4 factorial, 2 factorial, that's 4x squared, plus 6 times 5 times 4 times 3 factorial over 3 factorial, 3 factorial, times, we have the 8x to the power 3, plus 6 times 5 times 4 factorial over 4 factorial, times 16x to the power 4, plus plus 6 times 5 factorial over 5 factorial, this multiplied by 32x to the power 5, then plus, what do we have there? This one will be 1 easily. 0 factorial is 1, okay, so 1 times 64, that is 64x to the power 6. So cleaning all of this up, this 5 factorial will be out here. We have 6 times 2, which is what, 12, which gives you 12 here, okay, so all the answers just fall in place like that. So 4 factorial is out, 2 factorial is 2, so in this that will be 3, 3 times 5, which is 15, times 4, 60. Okay, so just go that way like this. 3 factorial, that's 3 times 2 times 1, which is 6. It will cancel out this. So 5 times 4, 20 times 8. So from there we have this like that, like that, like that, like that. So we have the same result in our both expansion. Okay, using the oh using the both Pascal's triangle and the binomial expansion formula. Expansion formula formula with the help of combination. Okay, thank you and God bless you, and that's it.